able to describe what the doldrums are, that they were this area of weak winds under the ITCZ. You have to take a tropical meteorology class to know why the pressure gradient force is weak there. You need to know about each of these cells. You need to know about the different jet streams. But this was all sort of predicated on one basic understanding of this atmosphere that was responding to both how it was being heated, where there was differential heating, there was more heating near the equator and less heating near the poles, and the fact that the Earth was rotating. Need I put back the Hardy Boys-esque essay again about the heaving mantle of air being warmed by the glow of the sun and twisted by the spinning of the Earth? That's what this really is. Basically, we just said, all we're taking into account is how the planet is heated and how the Coriolis force works, and we've figured out the general circulation of the atmosphere in this class. You certainly should be able, though, to explain these different features and describe them and know where they are with respect to each other. Another important thing to think about with regard to the general circulation is how it changes. You want to be able to talk about how over the course of a year, like how in particular the tropics, how it changes. That's the thing we focused on mostly, about how the ITCZ shifts north in our summer and south in our winter. And that gives a monsoon climate to places like West Africa or India or Australia, places where in the summer, when they're warm, the ITCZ shifts to the north. Let's say you're talking about Central America, just because it's right here at my level here. In the summer, the ITCZ shifts farther to the north. In fact, if you live in like northern Mexico or Arizona or New Mexico, you can get a little bit of a monsoon going on up there. As the ITCZ shifts north, because that's where the warmest air is, that's where the rising motion should be happening. And of course, when you're under the ITCZ with all those thunderstorms, that's your wet season. Then in the winter, the warmest area is down here south of the equator. The ITCZ shifts south of the equator, and we now see sinking motion in subtropical highs over these locations over Central America. And of course, sinking motion, no clouds, no rain. That's the dry season. So being able to put both of those two things into, to be able to describe both of those, both the basic situation of the general circulation, the sort of average or mean sense, and of course, then how it changes over the course of the year is very, very important. From general circulation, we encounter our first little bit of important stuff about the jet streams, and in particular, the thermal wind relationship. There are a number of questions about the thermal wind relationship on the test. First off, we got two jet streams up here, a mid-latitude jet stream and a subtropical jet stream. Only one of these is caused by the thermal wind relationship. You guys know which one?
Mid-latitude jet stream.
Mid-latitude jet stream. The mid-latitude jet stream has cold air on one side and warm air on the other. The subtropical jet stream has warm air on both sides. Right? The air underneath here it's the subtropical highs. It's like Bermuda and southern Florida and the Gulf of Mexico and so on. It's warm on both sides. No thermal wind relationship there. The thermal wind relationship is an interesting thing to try to write questions about. It's actually pretty hard to come up with good ATS 113 level questions about the thermal wind relationship. If you go back and look at either the PowerPoint presentation that I got set up there on the blue line for you, or if you go and look at those videos that are available to you on there or whatever, where I go through the whole PowerPoint with you, you will see that, in fact, I pretty much steer you towards the kinds of things I can ask. I mean, I kind of have that tell you what I'm going to tell you before I tell you kind of thing, where we're explaining why this happens, how it's related to thickness changes. Thickness changes are due to the temperature change on the two sides of the front. It takes a polar front for it to work. That's the kind of stuff you need to know most definitely. Thermal wind relationship and cyclogenesis, I think, are as complicated as this course gets, in my opinion. Those are the two hardest things. They were certainly the hardest for me, anyway. On the other hand, everybody loves the air mass questions. I don't mean... oops, why is that not working? That's interesting. Well, that's something to figure out it was. Oh, well. I don't mean to imply that the air mass questions are easy. What I mean to say is that the air mass questions tend to be something people are pretty comfortable with. Because you have many, many years of experience with questions that involve like lists, right? I mean, we had 5 different kinds of air masses, and my guess is in your notes you've got where all or else by reading the book or whatever. You have figured out where all these air masses come from, what makes continental Arctic different from continental polar, and what makes that different from maritime polar and all that kind of stuff, you're probably pretty darn good at that kind of thing. You wouldn't be here if you weren't. And so generally speaking, students do pretty well on those because they know how to study for that stuff. And that's good. We also know, so there are questions like what kind of air mass would bring warm, muggy air to Nebraska in the middle of the summer? And you would choose maritime tropical because it is warm and moist. Those kind of questions go so well for people. But there are also questions that are more like how air masses form. There are questions about how air masses modify. Those tend to go a little bit more rough for students. Keep in mind that all air masses are areas of high pressure. You can think of them pretty effectively as like pieces of the polar high or the subtropical high that have broken off. And broken off, I don't know if that's exactly right, but that's a good way to think about it. You can think of it as like pieces that are being dragged off of the polar high or the subtropical highs by the cyclones, as the rotation on the cyclone is like pulling air off of the polar high. That would be a way of thinking about it. I tend to think of them as pieces, whatever works for you. But everybody tends to do pretty well on the air mass questions. Fronts tend to be kind of a mixed bag. Some of the front questions everybody loves. You can well imagine, as is the nature, of the hiccups, of a course, we have to ask some questions. If you don't know the strategy of this, let me be clear. When we write questions on, or when we select questions from a question pool, more accurately, we have to choose some questions that are so easy that anybody who gets those questions wrong, that's an identifier that something was going very wrong, like they were off on the numbering. Okay? You ever think there's some questions on there that you're like, how in the hell? Yeah, it's because we need, something's going seriously wrong, or sometimes it's like test anxiety, or who knows what. But really, if you got that one wrong, we have to pull your test and go look what happened here, right? Oh, they got off by one question. Okay, we'll run it again. All right. We also have to have some questions, though, that are really, really hard. That's called testing top. The other one is called testing bottom. Testing bottom is when you have questions so easy nobody should be able to get them wrong. And we have to have some questions that are in there. It's how you tell the 95% from the 100%, right? Okay. It is easy to write testing bottom type questions for the fronts, right? Everybody's going to get a question about which type of front is fastest right. Nobody's going to have trouble with that. Nobody's going to have trouble about what kind of front is steepest. Or how do you draw a cold front on a map? That it is a blue line with blue triangular teeth, the direction that the cold air is advancing. Those kind of questions everybody loves, and they feel good as they move forward, and then they get snagged on the ones that are like compare and contrast. Okay, students are not happy with compare and contrast questions. They certainly aren't very happy with and then there's only 4 choices, A, B, C, and D, and especially they get least happy when there's an E trick question. Okay? Those that are higher on the taxonomy of knowledge type questions tend to be less popular. But you do need to prepare for those because some of your classmates are going to get them right? You need to be able to describe compare and contrast cold fronts and warm fronts, or for example, on the question on the quiz today where we talked about what the weather was like. For example, on the quiz today we had a question that was about, at first there were cirrus clouds, I believe, and then they went down to altostratus clouds, and then stratus and nimbostratus clouds. What kind of front was that was approaching? It was a warm front, right? Warm fronts first had those high clouds. The whole story there was about that big word overrunning. Right? That was an overrunning question. Being able to describe the weather. We had never done that before, right? We had never actually seen a question like that. When I talked about a warm front, did I say first you see this, then you see this, then you see this? No. That was you doing a great job putting things together. Okay? That's the kind of questions that become the next level up on the test, okay? I love questions. Well, I don't love questions. I love them in the sense that I respect the fact that they're even higher up on the taxonomy, where you're talking about why this type of front, for example, is not a polar front, and this type is. Right? We had different types of fronts that were and weren't polar fronts. Warm fronts, cold fronts, stationary fronts were, dry lines that included fronts weren't. I like types of questions that are about what you would experience. Okay, question today on the quiz that was about you were at a location and then you saw cirrus clouds and then you saw altostratus clouds or whatever. Another way to write that question would have been if you were moving. As you drove, you first saw cirrus